Saxon Advanced Mathematics, Lesson 89. Greetings, students. The ellipse, part 2. An ellipse, as you will recall, is nothing more than a fancy way to say oval. And we have had a lesson already in graphing them. So let me start by reminding you what we already know. We know that they can orient two different ways. So I'm going to do this for both orientations. We call... let me put in the points first. Put in 2 points on this x-axis about the same distance apart, and then put in 2 on the other 2 that are also the same distance apart, but a little closer than these 2. Then let's try to connect them all in a semi-decent, oh, I missed that one. Oh well, pretend it's perfect, right? Okay, this line, the longer line is called the major axis. This line is called the minor axis. We have names for the points. We call the major axis points the A's. So this would be minus A, 0. And then the minor axis we call the B's. It would be 0, B, and then 0, minus B, right? So we can fill those points in. We know that this distance is also distance A, right? Because from 0 to A is A distance. And then we can measure up or down, whichever way you want. I'll do it here. From the origin going up, that would be a distance of B, right? We know that we have focal point in here. We're going to talk a little bit more about the focal point in a minute. I'm just going to label them as F1 and F2. Remember, well, I'll talk about that later, so let's not worry about that for now. The last thing I want to show you is the formula for this. Because the major axis is the x-axis. Remember, we can always tell the major axis because it's bigger, but even more so because the focal points are on the major axis. We can say that x squared over a squared plus the minor axis over b equals 1. We always associate the a with the major axis, and the b with the minor. Let's draw the other set of pictures, and then that will help us make the contrasting difference. This time, we'll do the same thing, except our ellipse will be oriented up and down. Right? Oh my gosh, that is a pretty sad ellipse, but you get the idea. We always associate A with the major axis. This is the major axis. Let's go ahead and put our focal points in. F1 and F2, we usually call them. This point up here will be 0A. This will be 0 minus A. This is the major axis. This will be point B0, and this will be point minus B0. So again, we know something about the lengths of these. We know that this must be B, and this distance must be A. Okay? And then when we write the equation, this time we're going to we'll write the x squared still first, but x is the minor axis this time, so it's associated with the b squared plus y squared, and that's the major, equals 1. Could you write this with the y first? Yeah, you could. That would be fine too. Typically, we leave the x and y in that order, and then we move around the a and b to match the major and the minor. Okay, so this is what we already know. Beautiful, right? Now, let's draw one more axis this way, and I want to talk a little bit more about those focal points. So here we go. Make your 4 points, connect. That's my best one yet. All right, let's put in our focal points. And let's remember one thing. A is always the distance of half the major axis, right? This much is A. And then this is 0, and then we go A in this direction as well. So this whole thing is 2A. I'm just going to write in that point on both of these. That the full length of the major axis is 2A. Okay, now, I know I remember I told you this way back in the beginning, but we draw an ellipse by taking, pretend this is on a bulletin board, and we put in 2 push pins at the focal points. We tie a string into each of those push pins with some slack in it. Then what we do is we take our pencil and we pull it as tight as we can, depending on how long we made the string, and then we pull that string and let our pen draw a circle that represents the farthest that that string will let us move, all the way around till we come back up here, right? We have to have really strong thumbtacks in here so that we don't pull the string out, but we're just catching that string up in our pen and writing as far as it will let us go in this direction. Now, let me point out one other thing to you. When we have the string all the way to here, we can see that it is 2A long. It's 2 times A long, because look, the string would go from here all the way to here, and then this part would be doubled up, right? Because the thumbtack would be here, and we'd have another string over here, right? Do you see what I mean? So we can say that the length of that string is 2A. Okay, let me draw that with a blue pen. If we put our pencil in right here, here's our pencil, right? The string will be pulled all the way like that, and then like this as well, right? So at this point, you know what I want to do? I just want to do this so badly. There's no rhyme or reason. I want to put a little orange eraser on our pencil. There, that makes me feel better about it being a pencil. Okay, so when we pull the string taut to one side, the length of the string is 2A. So what happens then if we have the string like this? Not pulled all the way over to the side, but what happens if we have our pencil up like this? Right? I have to make it square. An eraser is not round. Okay, so this is my pencil and string up here. That string that is 2A is evenly divided into lengths that are A units long, because this is right in half of the 2 focal points. So half of it's on this side, half of it's on that side. That means the lengths of these angles, the distance from, here we can call this point 0B, right? The distance from F1 to point 0B, right, from here to here, equals A, which is half the major axis, which is what we proved back here, right? A is always half the major axis. I'm going to write that in here. A equals half major axis. Now, my friends, we know enough to be dangerous, don't we? We're going to take this and use that information to solve some fabulous riddles that John has cooked up for us. All right, I'll remind you of this as we go. This is what's new. We now know that we can draw a line from a focal point to the minor axis extreme, and that will be equal to half the major axis. Wow. Crazy, right? Okay. There aren't too many problems in this lesson. 1, 2, 3. My favorite number, right? My favorite number of problems. Not necessarily my favorite number altogether. Example 89.1. My favorite number altogether is 2, probably because I was a second born. Oh wait, no, that's right. Write the standard form of the equation of the ellipse with vertices, that's what we call the endpoints, at, so I'm going to write this down. Vertices are plus or minus 5, 0, and foci, that's the plural of focuses, at plus or minus 4, 0. Okay, so the first thing we always want to draw is draw the diagram. And I know that once I plot my focal points, I will know which one's the major axis, and that will help me quite a bit. Okay, so I know just by looking at this and thinking for a second, this means they're on the x-axis, right? It means that my thing is oriented this way, my ellipse is oriented this way. I'm just going to go out a ways and I'll call this 4, right? Because this is the point 4, 0, and this is the point minus 4, 0, and that relates to that. I better put dots there. And then I'm going to put a dot a little further out and call that the vertex. Again, we don't have to be super precise with our graphing. You don't need graph paper or anything like that. Okay, now I know there has to be a point up here and a point down here, but we don't know what that is yet. I'm going to draw my ellipse. Remember, the focus points do not touch the edge of the ellipse. They're chilling in the middle. Ooh. Pretend. Oh, please pretend with me. All right. So I know that these are the focal points. So I know that I can draw lines like that. Oh, please pretend they're perfect. And I know that I can figure out what this is. This distance is A. A equals 1/2 the major axis, and it also equals from 0 to the vertex, right? Same difference. So I can look at this a couple different ways. I can say that A equals this point. That's the easiest way for me to say it. It's 5. Okay, so I know that this value is 5. I also know that this distance right here is 4. So what I'm going to do is I'm going to pull out that triangle and draw it separately. This triangle here I'm going to draw here, right? This side is 5. This side is 4. What I need though, and I haven't even read this, it says write the standard form of the equation. Okay, we know what A is, and we have to find B. B is this value up here. If I can find the length of this side of the triangle, right here, then I will know the point up here and down there, and I'll be able to write my equation. Now, how am I going to find side B? Pythagorean, baby. Come to me. This is going to be easy, right? It's going to be A squared plus B squared equals C squared. But this A doesn't mean that A. This is the hypotenuse now. So it's going to be like 4 squared plus B squared equals 5 squared, right? We use the letters different ways in different problems. So the A that we're talking about in an ellipse is the hypotenuse. The A here is a leg. So we just have to be careful not to mix that up. We want this number to go for the hypotenuse. Okay, this is 16 plus b equals 25. We subtract 16. Oh, it's b squared. B squared equals 9. That means b equals, do we have to write plus or minus 3? No, because I'm telling you the length of that is not minus 3. So we know that b equals 3. Now, what can we do with this? We know that if that's the length of this side, then this point must be 0, 3, and this point down here must be 0, minus 3. Cool, but John wants us to write the equation. So now we know that a always goes with the major axis, so it'll be x squared over, a is 5, so 5 squared, plus y squared over our b, which is 3 squared, equals 1. And then just to be completely fancy, we can multiply those up. And so we would write x squared over 25 plus y squared over 9 equals 1. And that is the most perfect version of our answer. I would not be mad if you gave me this. If you gave me this on a test, I might ask you to just multiply that out for me, but I wouldn't subtract any points. This is perfect. This is pretty darn close. Okay, so that's how we can use our new knowledge about this distance to help us solve problems. Let's do another one. Example 89.2. Write the standard form of the equation of an ellipse with vertices at 0 plus or minus 6, there's a comma right there, and foci, focal points, at 0 plus or minus 5. Now we have to decide, are these on the x-axis or the y-axis? And if we look and think for just a minute, we go, okay, these are on the y-axis, right? Their values are in the y spot. So that tells me we're going this way. The vertex is at 6, 0, positive 6, 0, negative 6. There's going to be 2 points here. I don't know what they are yet. I'm drawing my circle. My ellipse. Oh, that might be my best one yet. The foci go in at plus or minus 5, so roughly here, right? This would be 0, 5. And then roughly here would be 0, no, that's right, 0, minus 5. So we need to draw our string going from the focal point to the vertex on the other axis, right? The focal point to the vertex on the other axis. That's how it goes. That is our side A, and in this problem, A equals 6. All right, I'm going to write that in. A equals 6. I'll put it all in one big circle. Okay, do we know the length of this side? Yes, we do, because we know that the focal point is at 0, 5. So that means that this side must be 5 units long. Cool. So this side I know is b. It's the length of the minor axis. So now I can use Pythagorean theorem again. This one's the hypotenuse. So I'm going to say 5 squared plus b squared equals 6 squared. Don't get tricked up by those a's again, right? The a and the, I didn't even write the Pythagorean down, so you wouldn't get as confused. But this is not the a for the Pythagorean theorem. This is the hypotenuse, so it's the c. Okay, solving. 25 plus b squared equals 36. We subtract, we get b squared equals 11. We take the square root, we get b equals the square root of 11. John wants us to write the formula, or the equation rather. And so we know that x squared is associated with the minor axis. It will be b squared. That will be 11. B is the square root of 11, so b squared is 11. Plus y squared. Y is the major axis. So we look at this length. It is 6, right? A equals 6. I have it right there. So then this would be 36. And we always write it equals 1. Yay. All right, one more. A horizontal ellipse has a major axis of 10 and a minor axis length 4. If its center is at the origin, thank goodness, because we don't have the means to deal with any ellipses that are not centered yet, find the coordinates of the foci and write the equation in standard form. Graph the ellipse. All right, well, we better start with the picture first. The major axis, he tells us it's a horizontal ellipse. That means it's going this way, and not eclipse, ellipse. That's a whole different thing. Okay, so here we are. I'm just gonna make some arbitrary dots. I'm not gonna try to count out 10 or 4. That's crazy. That's not my best one, but it's okay. So this point is 10, 0. This point is minus 10, 0. It helps to just write all this down. This is 0, minus 4. This is 0, positive 4. There's foci in here, but we don't know what they are yet. But we know that we can draw a triangle here. This side must be 4. We know that A, this side, equals half the major axis. The major axis is 10. No, I did this wrong. The major axis is 10, so this is 5. Minus 5, and this is positive 5. And this is 2 and 2. Do you see what I did wrong? I forgot to divide these in half. Let me just write that over. Do you see what I did wrong? That's a really common mistake. I read the major axis and I just used that number as the point, but it's not, because the major axis is this whole different distance. So if this is 10, then these have to be 5. And the same thing this way. If the whole axis is 4, then these have to each be 2, right? Aha! I caught myself in a really good mistake. A, this length, is half the major axis. I'm just going to write that down again. A equals 1/2 the major axis. And that means that this number must be 5. So now we have 2 of the 3 values that we need on this triangle. And we can say that 2 squared plus, what do we call this? Let's call this, we'll just call this b, plus b squared. That's not right. Let's call this c, because this is technically b, right? We use b in these problems. Okay, c squared. I'm doing a lot of scribbling out this time, aren't I? Hey, life is real. Everyone makes mistakes. It's not, this should be 5 squared. Life is real. Everyone makes mistakes, including me. Okay, can you read that? 2 squared plus c squared equals 5 squared. So let's quick try and fix this. equals 25. Subtract the 4, we get c squared equals 21. Take the square root, c equals the square root of 21. All right, right along here. Now, what does John want us to do with this answer? He says, write the equation in standard form, find the coordinates of the foci. Okay, well, when we figured this out, we figured out the coordinates of the foci, right? Because this length is square root of 21. So F1, I'm gonna write my answers here. F1 equals negative square root of 21, 0. F2 over here is positive square root of 21, 0. I haven't said this specifically, but whenever we draw one triangle, we could always draw the other one on the other side, right? They're identical triangles. So we can draw whichever one is clearer in your mind, like how to see it. I tend to draw them on this side, but you can do it however you want. Okay, so there are the points. There are the points of our two foci, and then our equation will be x squared over 5 squared, right? Because this distance is 5 and minus 5. So this whole distance is 5. So I'm going to write 25 because it's squared. Plus y over this distance squared, 4, equals 1. So here is our answer box. I hope I did not confuse you with my mistake here. The major axis, this number does not give you this point. Half of this number gives you this point. The minor axis does not give you this point. Half of that gives you this point. Sometimes I think mistakes, when I make a mistake, it's almost helpful because it allows you to experience the mistake through me, let's just say, and hopefully you will not make it yourself. This is the right answer, I think. Let me check. Square root of 21, 0. Yes. Yes. Oh, I forgot this. Beautiful. Okay, that's the end of lesson 89. I hope you enjoyed it. That's a fun lesson. I hope I didn't ruin it for you with crazy mistakes, but I just love that one. Thank you. Goodbye.